Everyone, thanks for having me. Welcome to my talk about collaborative editing in Jupyter Notebooks. This talk is going to be mainly about the past and current efforts that we undergo to make Jupyter Notebooks more collaborative. First, a bit about me. Hi, I'm Kevin Jahns. I'm an open source developer and a freelancer, and my mission is to make the web more collaborative. For this, I developed Yjs, a framework for building any kind of collaborative applications. It possesses a huge ecosystem of toolings that allow you to build feature-rich collaborative applications, but more about that later. What exactly is collaborative editing? Personally, I mainly think about Google Docs. Personally, I was so impressed when it was released in 2006. And for the first time ever, I was able to work with my peers, back then it were my schoolmates, collaboratively on the same document at the same time. I was able to manipulate the same position that another person was editing at the same time. And there was no conflict. Everyone just ends up with the same content. Also, it has these nice features that allow me to have some kind of idea of what other people are currently doing and what they were doing in the past as well. So I can see an edit history. I see user cursors, and each user is associated with a unique color. Really, there's an open end of features that you can add in a collaborative application to enhance the collaborative experience and allow more and more people to efficiently work together. I believe that this is the future of the web in general. And I'm really excited about our efforts in JupyterLab specifically. So JupyterLab was, I think, Jupyter Notebooks was created in 2011, I think. And ever since then, collaborative editing has been the single most requested feature for Jupyter Notebooks. And many people have tried to integrate a collaborative experience. And this started in 2013 with some Google engineers. They, however, made a complete rewrite, Google Colab or Collaboratory, and they based their efforts on the proprietary Google real-time engine, which is now deprecated. So unfortunately, Google Colab is not collaborative anymore. There has been another effort by William Stein. He wrote CoCalc, also from the bottom up, a complete rewrite with integrated collaborative editing features. It was only in 2015 when the first people started to actually integrate collaborative editing into JupyterLab. And now it has been taking us 6 years, actually more, to get a product that you can actually use to to collaborate with your peers on Jupyter Notebooks. I joined this project in at the beginning of this year, and my mission was to integrate Yjs, which solved several of the problems that we had in previous attempts in integrating collaborative editing. And yeah, we made it. Actually, during this year, we released JupyterLab 3.1, which includes collaborative editing features, and you can enable them by just adding --collaborative when starting your JupyterLab instance. This works when deploying this locally, but of course also when deploying it remotely or on a binder instance. In this demo here below, you see that we have a binder instance and it has a share button. And when we click the share button, you get a link that you can send to other people. So this is already a super useful feature, but it's still hidden behind a feature flag. So this is why I started my own JupyterLab instance locally. I have 2 browsers open, and I'm going to open the same document at the same time. So I can see the content from the left and right window synchronizing with each other while I'm typing text. And you already see that when I type text, I see the selection of the other window is highlighted with the user color. And we also associate a unique username that is associated only with me, and a unique color that is also only associated with me. Unfortunately, we don't have user management yet in JupyterLab, so everyone is an anonymous user, and we assign usernames based on the moons of Jupyter to each user. So I think that's really cool. But yeah, for now, everyone is going to be anonymous until we integrated real user management. And yeah, you can basically do everything collaboratively if you want to. You can write some code, you can execute that code, and the output is also synchronized. It includes all the basic functionality that you would expect from a real collaborative application. For example, real undo redo behavior. I would like to get a question right now. If you want to, Jack B, if you raised your hand, please ask a question. I try to answer it in the chat. Unfortunately, I don't see the chat yet. Here we go. Yes, this is built in, and you can use it right now using the -- collaborative flag. Just pull the latest JupyterLab instance and start your instance with collaborative. And then your deployment will be synchronized with all the users. So you can, like here, just open a file and work on that collaboratively. You can rename files, everything just works collaboratively. This is already, you see, we have some smaller problems here, but this works really well for now. We already use this product for the JupyterLab notebook community meetings, where we have something like 20, sometimes up to 30 people working on the same notebook. Unfortunately, when we have a lot of users, sometimes we have some issues because of the approach that we took to integrate into the existing backend. But more about that later. Is this already available? Yes, it is. You can use it on Jupyter Hub with a single flag. And I think we can, I will answer the other questions later on. All right, this is it about this demo. And I encourage you to try out this demo. But why is collaborative editing actually so hard to implement? Why did it take us something like almost 10 years to add this collaborative editing feature? Is it really that hard to implement? And I want to get you some kind of idea of what the problem actually is when building a collaborative application. Because suddenly you start with a single user application, and suddenly you have to deal with concurrency because your application can be manipulated by several users all at the same time. So you have to deal with concurrency issues. And here I illustrate a very simple concurrency issue that we need to solve. In this example, we have two users, the left user and the right user, and they both insert a character into the existing document. The left user inserts character A, and they end up with, and they apply that change first on their local version of the document, and then propagate that change to the other side. The right user inserts character B, and then propagate that change to the other side as well. And now the other user is going to apply the operation from the other user respectively. So the left user first applies their own operation, insert A, and then insert B at the first position. They end up with BA, but the right user first applies insert B and then insert A, and they end up with the document AB. So clearly the documents diverge. How can we solve these kinds of problems? Yeah, and this has been an active area of research since 1981. And so far it took, I think, almost 10 years to solve this problem initially. And then in 2006, we had the first, well, wide-scale application using an algorithm that solves this problem, which was Google Docs. And now we are slowly getting more and more collaborative applications, and that you know probably from work or maybe from other areas of your life. And Yjs is one of the solutions that you can use to build collaborative applications. Yjs itself implements a CRDT, which is a conflict-free replicated data type. It's really complicated. It's a mathematical model to merge concurrent actions. And the idea is basically, internally, there's a lot of magic going on, but Yjs exposes easy-to-use data types that you can manipulate concurrently by other users, and then you can always merge these data types together. In this example here on the bottom right, we start with a root document, which is an empty document, and one user forks this document and inserts a character A into their representation of the document, and another user forks this document as well and inserts character B. think about this as a Git branch, 2 branches, and now you want to merge them together. If you use Git, you have to manually resolve these conflicts, but with Yjs, there's automatic conflict resolution, and you always end up with the same content on all peers. This is some of the magic that Yjs provides. So in theory, everything that we would need to do is to represent a Jupyter Notebook, the internal model that we use, on top of Yjs data structures, and then in theory, we should have collaborative editing functionality. And this is exactly what we did. We actually went a bit further and created a really nice API around shared notebooks, which we call a shared notebook. This API allows you to easily manipulate cells, to insert content, to read what is currently in your notebook, to get the output and the metadata with the output in a convenient way. You can do all kinds of manipulations, but in a safe way. So when you do an invalid operation, you will receive an error, and you also have type information that prevents you from doing stuff that is not allowed to do. And yeah, so far this has been a really great abstraction that made the role of JupyterLab itself very easy to use, very easy, much simpler. Because the Jupyter UI only needs to listen to changes from the Jupyter Notebook and render them in the interface. It doesn't have to deal with the representation of the shared notebook anymore. And it is actually now fairly easy to build your own custom Jupyter UI to render your own custom representation of the notebook. For example, maybe you want to use a different editor. All of that is now easily possible. For extension authors, this is great, because for the first time, it is easy to extract the content from a Jupyter Notebook and also observe in real time when something changes. You get easy to use, easy to understand events whenever a cell is added, or when content to a cell was added, when metadata was manipulated. This is not hidden information anymore. We expose this in a great interface that is typed in TypeScript that allows you to, well, now build features that you weren't able to do before. And also, you can deal with all the collaborative scenarios. Like, for example, you have access to the awareness information, which includes, for example, the number of users and which user are currently online and where their cursor location is. You can use this to render some additional meta information on top of your current local user, for example, in order to provide a help dialog. And you can also maybe provide custom collaboration extensions that use awareness information to provide additional context that is important for your specific scenario. And yeah, and if all of that is not enough, you can use Yjs for adding custom features. In the coming month or in the coming year, we want to add extensions API immensely, and also add a commenting API and then annotation API, so that extensions can use to store information and also annotate the Jupyter shared notebook itself, so we can provide additional information. Yeah, and finally, of course, we need to synchronize the shared notebook with other peers. Sorry, I'm currently reading some of the questions. Okay. We also need to synchronize the shared notebook with other peers. And what we do in here is we synchronize basically the Yjs model through a communication protocol. There's an existing concept that we call Yjs providers that allows us to listen to CRDT updates and synchronize that over a network. For JupyterLab, we built a very easy Python implementation of a server that accepts Yjs updates and just forwards them to all the other clients. But in theory, you could use a different provider as well. For example, there's going to be a backend service that you can use to build highly scalable applications that have very low, that allow a lot of users to work together, that scales much more efficiently than you could do on your own. And you could just plug in the shared notebook to that highly scalable server in order to provide to use a different backend. You could also use WebRTC to provide a completely decentralized peer-to-peer experience of your product. And this is basically what Jupyter Lite is doing at the moment. You should check it out. JupyterLab by Jeremy Tulop. It's very interesting what he's up to. Yeah, and so far this has been our biggest contribution to this project. Now we are working to migrate the client-server protocol from a non-collaborative experience, which was only meant to be a single user application. So you see this on the left. The current Jupyter server implementation expects that it only needs to send documents to the client and then save a notebook. So there's no incremental updates that we have to handle. The editing experience is basically client opens a notebook, you receive back a JSON document, and then you make some changes. And at some point, a few minutes or hours later, you save the notebook. And if something happens in between, all the changes are lost. A true collaborative mode will request a notebook and you get back a Yjs document. And from then on, you can make incremental changes and synchronize each incremental change with the server itself. You see there's no save notebook API anymore. It is always synchronized with the backend. And you can be sure that whenever you close the notebook, your latest changes will be stored, synchronized. Now, there's a problem you might have noticed, because Yjs itself is a JavaScript implementation for conflict resolution. We currently don't have a Python implementation, but the Jupyter server is a Python implementation of a server. And yeah, currently the Jupyter server is not able to understand and read the content of a shared notebook. But we want to change that with the Yjs CRDT project. It is a very ambitious project to port Yjs to many, many different languages. We want the whole ecosystem of many different languages to be able to understand each other. So a Swift application, an Android can communicate with an Android application, and they can communicate with a web application, and they can also communicate with the Python server, of course, based on a single Rust implementation of the Yjs CRDT that we are currently working on. We are generating language bindings to other languages like Python, C, and Java, and WASM. And you can use them to build. They provide all the functionality that Yjs provides. But the advantage is that we don't have to make changes to all these different ports, because all these ports are automatically generated. Once all of that is done, and we are confident that the Rust implementation works, we can use the Python package of this Yjs CRDT implementation to build our own shared model implementation for Python. We could even use the same approach that we are using in the Yjs CRDT project to port the shared model to many different languages. So you could maybe interact from a Java implementation with your notebook, if that is something you want to do. And finally, this will allow us to implement a proper multi-user backend with a true collaborative editing scenario capability in Jupyter Notebooks. I see in the questions that somebody is talking about Jupyter Hub, and you're right that there are Jupyter Hub. I might have misunderstood the question here. So our plans for 2022 is to enable collaborative editing by default and make that the default experience in JupyterLab 4.0. We will actually remove the non-collaborative mode completely and just expect that everything is collaborative all the time. And we want to add more collaborative features, like, for example, commenting features, chat, and version history, and allow you as extension authors to add more and more collaborative features. I imagine that in 2022, you would have, you will be able to restrict other users from doing certain things on your notebook. For example, you only want other users to do commenting, and other users you want to give full access to your personal notebook, which is maybe on your local computer or maybe on a server. We want to integrate this experience in Jupyter Hub, but also build custom interfaces. Yeah, so far we have a lot of great ideas, and I encourage you to join the RTC community meetings that we announce in the Jupyter calendar, and join there if you have questions or if you want to build extensions on top of this. I want to thank you for joining my session. This work wouldn't have been possible without the Schmidt Foundation, the Alfred P. Sloan Foundation, and Cal Poly, who funded this work through QuantStack, where I'm currently working at. And I want to thank all the great people who encouraged me to build this and who introduced me to the JupyterLab ecosystem. And now is the time to maybe answer some of the questions. Do you want to read these questions or should I read them?
How do you prefer? We have so many, I'm so excited. There's so many questions here. And we have questions in the Q&A that are open. We also have questions in the chat. So I think maybe we can take, how would you prefer? We have 7 minutes left. In worst case scenario, if you cannot answer everything here, you can go to the talks channel or gather down to continue the conversation.
Yes, I think I will just pick some of the questions from the chat, from the question and answer chat, because there are some that I want to answer.
Perfect.
There's this one question by Eric, who says, expecting collaborative all the time seems dangerous. I'm not sure about that. I mean, we want to migrate to a safe collaborative editing experience, and supporting two modes, a non-collaborative and a collaborative mode, as we do at the moment, is actually the dangerous part. We had to undergo great length to support a non-collaborative and a collaborative mode without breaking any of the existing API. What we do at the moment is basically we start in a non-collaborative mode where we load the JSON, and then we have a specific locking mechanism that forces all the users to migrate to the collaborative mode. And then from time to time, you still need to save the notebook. And what you need to do is to, again, use the locking mechanism to switch back to the non-collaborative mode to save the notebook. So really, once we have the Python implementation, switching over to a pure collaborative mode is actually the much simpler approach and much safer. And this is not something that is experimental, like Yjs is not experimental anymore. We have many different products using migrating from non-collaborative mode to collaborative mode, and this is nothing new. This is really something that will make everything easier for us, that will reduce the code base and finally allows us to have true collaborative editing capabilities by default. But that doesn't mean that you are not able to work on your document as a single application anymore. Okay, there's another question. How does collaboration work when we are not on the same network, and how is authentication handled? This question was asked by Wouter Swart. And if we are not on the same network, we can't communicate with each other at the moment. We have to have some kind of deployment of JupyterLab. This can be a binder instance, but this can also be your own server, maybe a university server that has some kind of password protection. We don't really do user management, and we also don't restrict certain users from joining a session. So you need something like Jupyter Hub to prevent certain users from joining, to enforce that you have to have authentication. But yeah, in the future, we want that to change. We want to have an option to use maybe GitHub as authentication mechanism, and also use GitHub to prove that a certain user is who he says he is, or she is. And okay, the next question. What happens when people have different versions of the library installed? You probably mean the shared notebook model, this one. We keep this compatible. We have a major version number in shared models that is only incremented when we do breaking changes. So in theory, like we can have different versions of shared model sharing content with each other. But I expect that in Jupyter 4.0, we will have some breaking changes, which we will then keep for quite some time. By the way, the shared model is very oriented on top of the JSON schema for Jupyter Notebooks. So basically, they are fairly equivalent. And I don't expect that we make a lot of breaking changes in the future. I think the next breaking change that we make is the last breaking change that we will make. So you will be able to use old versions and they will be compatible with newer versions. By the way, I think I didn't mention this, but check out this package. Shared Models is a single contained package that you can use to build your own applications. It does not depend on the whole JupyterLab ecosystem. It actually has only very few dependencies. And there's some documentation here that we will also later extend. Then I can execute a huge job in a cell in someone else's notebook that breaks the kernel. This question comes from Eric again, and that is a really good question. Yes, if I deploy on my local computer something, and you have access to my local computer and collaborate with me on my computer, you are able to execute cell content on my computer. We want to restrict that. Currently, we don't even have that possibility because you need to have a deployment to really collaborate with other people. But in the future, we want to restrict access to only allow certain actions to be performed from another user. And we have many ideas how we can solve that. But at the moment, we don't really allow things that weren't possible before. We just synchronize content all the time. If a user has access to your notebook in your current non-collaborative instance and executes a cell, they can also execute and break the kernel if they want to. By the way, there is a possibility to use different kernels for different users or use the same kernel for all users. That is already possible. You just have to select the same kernel if you want to use the same kernel. But I think the default behavior is that every user has a different kernel.
Okay, Kevin, unfortunately, our time is over.
Okay.
I thank you so much once again for being with us and giving a talk at PyData Global 2021. If you would like to continue the conversation, I encourage you to go to the Talks channel or Gather Town. Thank you so much for being with us, Kevin.
Thank you for having me. It was fun. Thank you.